So this is going to be part 2 of the section 4.3 lecture. And for this part, I think we're going to do, so this is the second video for section 4.3. We're probably going to wind up doing 31 to 45 odds. And then we'll probably skip 47 to 54 because they have some theory that overcomplicates the section, and we'll skip those just to make it not get overcomplicated, and then we'll do 55 to 78 odds. So for this part of the video, we'll focus on 31 to 45 odds and 55 to 78 odds. First group of problems are just more calculator problems that I can't do without a calculator. And this is where you're going to find out if your calculator's good or average at best. On my calculator, for problems 31 through 42, where the instructions say use a calculator and round to 4 decimals, when I do a square root on my calculator, it doesn't give me a decimal. That turns out to be a good thing. So if I'm going to try to do problems 31 through 42, which is just use your calculator and get a decimal equivalence, round it to 4 decimals. On my calculator, when I do problem 32 and I do the square root of 6, my calculator comes back with the square root of 6. That turns out that that's an awesome thing for my calculator to give me. It makes it so that when we get deeper into the chapter, my calculator is going to be superior to a calculator that gives a decimal. If I want a decimal on my calculator and my calculator gives me an answer that's not a decimal, I hit this SD button. This SD button changes any non-decimal answer into a decimal. If I hit it again, it turns the decimal back into a non-decimal if it can. So this first answer for problem 32, my calculator gives me 2.44948, and I'm only going to write 5 decimals down to explain the rounding. If I'm rounding to 4 decimals, the number in the 4th decimal place either is going to stay the same or it's going to bump up by 1. If the number after the 4th decimal, the number in the 5th decimal place, is 5 or bigger, I'm going to round that up. Because the number after the 4th decimal is an 8, which is bigger than 5, I'm going to round that 4 up to a 5. And for an answer for problem 32, I'm going to put a squiggly because this is a rounding. I'm going to say the decimal approximation for this is 2.4945. I'm going to move down and do 34, do 3 square root of 5. I don't need the times key between. I hit equals, gives me a radical, which is really good. I'm going to hit the SD button. And for 34, if I'm writing down 5 decimals to figure out how to round my 4 decimals, it's 6.7082. That number in the 4th decimal place is either going to stay a 2 or it's going to round up to a 3. That has everything to do with the number directly in the 5th decimal place. The number in the 5th decimal place is 5 or bigger, you round it up. If it's 4 or less, you leave it the same. Because it's a 0 there, I'm going to leave that a 2. And I'm going to say this is approximately 6.7082. 36, it would be so nice if when I entered 36 on my calculator, if my calculator didn't give me a decimal answer, but my calculator does. It's a kind of a flaw to this calculator that every calculator has. But to do this, I'm going to do Shift and cube root, type the number 12, and hit equals. And I'm going to write down 5 decimals, so 2.28942. Again, you look at the number after the 4th decimal in the 5th decimal place. If it's 5 or bigger, you round the number in the 4th decimal place up once. If it's 4 or less, you keep it the same. I'm going to keep that 4 the same, and I'm going to say this is about 2.2894. 38 wants me to do the 4th root of 20, so Shift and this exponent key. fourth root of 20, and I get 2.11474. The number in the fourth decimal place is either going to remain a 7 or round up to an 8. That has to do with the number in the fifth decimal place. Since that's not big enough, I'm going to leave that at a 7. Right, 2.1147. To do problem 40 on my calculator, I'm going to have to do 3, type the times key, and then use this template. So it's 3 times shift x with this exponent and then fifth root of 40. And my calculator gives me 6.27383. The number in the fourth decimal place is either going to remain an 8 or bounce up by 1. Here it's going to remain an 8. So I'm going to say this is 6.2738. This has been pretty easy rounding. And then the last part here, until we get to a new concept, 4 plus 3 square root of 6, SD it. My calculator for this one says it's 11.34846. The number in the fourth decimal place would either stay a 4 if the number after it was 4 or less, or go up to a 5 if the number after it was 5 or bigger. Here it's going to go up, and I'm going to write 11.3485. So those are kind of mindless, just getting you used to your calculator. My calculator might work different than yours, so if you're having calculator issues, let me know, and I'll try to walk you through how your calculator should work. These next problems aren't really they're not on the test. And the reason I wrote these next few problems is very specifically that when we're doing square roots with letters, it matters whether the letter stands for a positive number or a negative number. And quite honestly, the theory that's embedded in problems 43, 44, 45, and 46, it's more confusing than it's worth. And the theory that's in these problems carries through 47 through 54, which we're going to skip that theory because it's something that is consistently skipped as you get higher. But the idea behind these problems, I'll show you. They're not on the test, but for 44A, it wants me to do the square root of 5 squared. Well, I know that 5 squared is 25. So this is really just asking me to do the square root of 25. And the square root is always asking me what positive number squared equals the radicand. For 44A, this is asking me what positive number squared is 25. And that's going to be 5. I could have just done this whole thing on my calculator. I could have did the square root of 5 squared, entering the problem look exactly like it looks, and my calculator says that that's just 5. For the next problem, negative 5 squared under the radical, to do the square root of negative 5 squared, I can do that multiplication. Negative 5 squared means negative 5 times negative 5. Negative 5 times negative 5 is positive 25. And the square root of any number asks what positive number squared equals the radicand. The square root of negative 5 squared, which is the same as the square root of 25, is also 5. I can enter this exactly like this on my calculator as well. On my calculator, I could do square root, parentheses, negative 5 squared, and my calculator tells me that that's equal to 5. So the issue when we're dealing with x's are letters. The square root of 5 squared, so what I have here is the square root of positive 5 squared is 5. The square root of negative 5 squared is 5. And there's kind of a theorem or a concept here. Basically, it says the square root of some generic number is that number when the number is 0 or bigger. Similarly, the square root of 8 squared would be 8. The square root of 9 squared would be 9. I could show you those on my calculator if they don't fall off the screen. Like the square root of any positive number squared. The square root of 8 squared is 8. The square root of 9 squared is 9. The square root of any number squared is that number if that number is 0 or bigger. But here, the square root of a negative number squared is not the negative number. It's the positive of it. And that's the ugly thing. So, for instance, the square root of negative 6 squared is not going to be negative 6. The square root of negative 6 squared is going to be 6. Similarly, the square root of negative 7 squared, it's not going to be negative 7, it's going to be 7. The square root of negative 7 squared, negative 7 squared is going to be 7. So this is going to say, theoretically, that the square root of some number squared equals to the positive of that number, which is the absolute value of that number, when the number is negative. And this is evil because when I'm dealing with letters, the letter doesn't always have a sign, but the letter represents a number. When I look at the square root of x squared, I don't know if the x is representing a positive number or if the x is representing a negative number. And because when I'm doing the square root of a letter and the answer needs to be positive, because I don't know whether that letter represents a positive or a negative number, it's proper when you do the square root of a letter to make the answer positive. So the square root of y squared, it would be wrong to say that the square root of y squared is y. If y represented a positive number, it would be right to say the square root of y squared is y. But if y represents a negative number, it would be wrong to say the square root of y squared is y, because here, that would be like saying the square root of negative, like here y was negative 5. The square root of negative 5 squared isn't negative 5, it's positive 5. Properly, when we're doing square roots with letters, because we don't know whether the letter represents a positive or a negative number, usually we make the number positive by throwing absolute values on it. That's the theory that comes up in problems 47 through 54 that I skip over. Because it's not the focus of our course. It doesn't come up in higher courses, I think, ever. So this is technically how we're supposed to do square roots with letters. If the square root of a positive letter is going to be a positive number, the square root, if a letter represents a negative, needs to be that letter made positive. It turns out that if I put absolute values on this answer, the absolute value of a positive number is still that number, so this is safe to do. So this is never my best lecture, but in general, in the big theoretical world, when you're doing the square root of a letter squared, it should be that letter with the absolute value because you want the answer to be positive. And even though it looks like the letter is positive because I don't see a negative sign, this letter is just a placeholder for a number, and the number that it's holding a place for may be positive, it may be negative. So technically, when we're doing square roots with letters squared, you should get an absolute value. There's more to the theory, but I'm not going to go further because I'm not going to test on it, but I can explain to you deeper theory if you want. Problem 46 isn't so worrisome with cube roots because answers can be positive or negative. It doesn't matter. I don't know why this probably should be the cube root of 3 cubed, just to make it consistent. The cube root of 3 cubed, shift cube root 3 up arrow cube. The cube root of a positive number cubed is that positive number. The cube root of a negative number cubed is that negative number. So unlike square roots, where the square root of a positive number squared is that positive number, the square root of a negative number squared is the positive version of that number. With cube roots, it's not an issue. The cube root of any number cubed is just the number that's being cubed. The cube root of positive 3 cubed is positive 3. The cube root of negative 3 cubed is negative 3. So the cube root of x cubed is just going to be x. I don't have to worry about forcing my answer to be positive, because the cube root of a negative cubed is a negative, the cube root of a positive cubed is a positive, and with letters, when you have an odd index, it doesn't matter when you're doing the radicals. Not terribly important. I'm sure not that great of a lecture either, but I feel obliged to say it's technically appropriate when we're doing square roots with letters. Absolute values get to be a consideration, but not something we're going to consider. The next group of problems would be 47 through 54. These all have to do with letters and doing radicals and when you need to do absolute values. And we're going to skip those. We're going to skip 47 to 54 in section 4.3. And left for this part of the video is 55 through 78, and I might run out of time because these videos hiccup at about 25 minutes. So I'm going to crunch down my theory and just get into how to do these. When we're dealing with letters, super easy to do the radicals. So, and the next group of problems are 55 through 78. To do the square root of a multiplication, you do the square root of each separately. So the square root of 16b squared is going to be the square root of 16 times the square root of b squared. I can't do the square root of b squared on my calculator, but I certainly can do the square root of 16. The square root of 16 is going to be 4. And to do the square root of a letter, you divide the exponent by the index. Here, the index is 2. And to get rid of the square root symbol, I just take the exponent of 2, divide it by the index of 2, and 2 divided by 2 is 1. I say the square root of b squared is going to be b to the exponent 2 divided by index 2. This is just going to be b to the first power. So I claim the answer to 56 is 4b. And if I want to check, anytime I write an answer down, to check to make sure that 4b is correct, anytime I do a square root, I should be able to take my answer and square it, and it should equal the radicand. So my answer is 4b. I'm going to check by squaring, because when you have a square root, your answer should equal the radicand. Your answer square should equal the radicand. To do 4b squared, I'd have to do 4 squared and b squared. 4 squared is 16, b squared is b squared. Because my answer squared equals the radicand, I know my answer is right. I can check all these, but I'm so crunched for time that I probably won't check any of these. In problem 58, this is a square root, so there's an implied index of 2. And to do the square root of any letter, you're just going to take the exponent of the letter and divide it by the index. So to do the square root of y to the 10th, that's really the second root. There's an implied 2 that's not written, but it's assumed. You're going to divide the exponent by the index, and this is going to give me y to the 5th. For 60, this is the square root of x squared, square root of x to the 12th. I'm just going to go x to the 12 divided by 2 and get x to the 6th. For 62, the index is 3. To do the cube root of a letter, I'm going to take the exponent and divide it by the index. In this case, the exponent is 12, the index is 3, the exponent divided by the index is 4. For 64, I'm going to separately do the square root of 36 by either using my calculator or what I know. And for the square root of x to the 20th, I'm going to divide the exponent by the implied index of 2. Square root of 36 is 6. When I take the index and divide it into the exponent, I'm going to get a 10. The answer for number 64 is going to be 6x to the 10. For 66, I need to do the cube root of 27 and the cube root of 9 and the cube root of y to the 9th. The cube root of 27th I have memorized. You could use a calculator. That's 3. And for the exponent, or for the letter, I'm going to divide the exponent by 3. And I'm going to get 3y cubed. Just because I'm running out of time on this video, I'm going to do the numbers in my head. You can do the numbers on your calculator. For 68, I need the 4th root of 16 times, I don't usually write a times symbol, but you can. It's implied if you write the radicals next to each other that they're being multiplied. The 4th root of 16, real quickly, shift square root 4 and 16. The 4th root of 16, shift square root 4. 4th root of 16 is 2. And then for the exponent, it's the exponent of 4 divided by the index of 4, and you get an exponent of 1. So my answer for 68 is just going to be 2z. For 70, I have to do the square root of 9, the square root of x to the 10th, there's an implied index of 2, and the square root of 16. The square root of 9 I have memorized to be 3. For the x, I divide the exponent by 2. The square root of 16, I know that that's 4. So for my answer for 70, it's going to be 3x to the 5th over 4. For 72, I need to do the 4th root of 256. I'm running short on time, so I'm going to do some work in my head. And for each of the letters, I have to divide the exponent of that letter by the index of 4. So I'm going to get x to the 4 over 4, y to the 8 over 4, z to the 12 over 4. For the 4th root of 256, it's going to be 4. The x is going to wind up having an exponent of 1. It's going to stay in the numerator. The y and z will stay in the denominator. The exponent on the y is going to be 2, and on the z is going to be 3. For 74, I need to do the square root of 9. It's a square root, so for the letters, I'll divide the exponent by 2. I need to find the square root of 49, and for the y, I'll divide its exponent by 2. Square root of 9 is 3. X to the first power in the numerator. In the denominator, the square root of 49 is 7, and y squared in the denominator. For 76, 4th root of 16, whatever that reduces to goes in the numerator. In the denominator, 4th root of 81. For the letter y, divide its exponent by 4. For the letter z, divide its exponent by 4 and leave the letters where they started. 4th root of 16 I have memorized to be 2. You can use your calculator. In the denominator, 4th root of 81 is 3. In the denominator, the exponent on the y is going to be 1, so I'm not going to write it. It's going to be assumed. The exponent on the z is going to be 3. Last one. I do the square root of 1 over the square root of x squared. Square root of 1 is 1. And for a square root, you divide the exponent by 2. And 2 divided by 2 is 1. I don't need to write that exponent of 1. It's just going to be